drawing the shape. The figure below shows two views of an intersection of a cylinder and a cone. Draw the following: the two views and determine the interpenetration line. B. Develop the shape of the hole in the cone. C. Develop the pattern of the cylinder using B as seen. So let's look at what is expected of us from the question. From the question here, we can see that there is a cone. All right, we have a cone here, and we have a cylinder, this one at the top, supposedly going to penetrate this cone from the top. So once we're used to cones that would intersect at an angle perpendicular to the axis, yeah, and at an angle inclined to the axis or perpendicular to the surface. But this time around, we've gone up, where the axis of the cylinder is exactly parallel to the axis of the cone. No need to fret. It's the same procedure that we're going to employ here. And we have the plan, the cone, and the cylinder showing right here. So we have all the dimensions of set here. So we would look at that and start solving the point. So let's start. The first thing to do is to draw cutting planes through the two objects to be to intersect each other. So we're going to do that. Go in this way. Get your arc, your pencil, the compass, and extend it to the end of that particular cone. Drop it right here. Yeah, as is with the normal tradition of what we normally do, extend this to touch the circumference. Okay, I had my semicircle further divided into 6 equal parts. So if it were a full circle, that would be 12. But I have it divided into 6 equal parts. That means that half the semicircle is going to run from 0, 1, 2, 3. And then from 3, come down to 2, 1, and then back to 0. So using BB as same, we'll address that later, but let's run cutting planes like I said. So there are cutting planes now touching the surface of the cylinder. Cutting plane 0 touching this, 1 touching this, all of them all touching the surface of the cylinder. What we're going to do now is to project all of these points, transfer them to the other side of the cone. So we'll do that right away. And here we go. 1 here. I've cutting plane 1, 1, 2, 3 in the center. Up 2, 1, and then we're back to 0. Right. So let's clear this off, trim them. They'll be able to use them nice and cool. So let's go this way. Let's go this way. So here we go. All of those points would have to trace them back on the plan view. So we would do that right away and trace them, find their addresses on the plan view. So start with this, go this way, go this way, go this way, and then back on the plan view. You find out that they are all passing through the plan view, but touching the center line. So we're going to use that as a tool to find what the address of all of that point is going to be on the plan view. So I have this right here. So because this is a cone, it will run from the center, from each of those points, and go in a circular fashion like this. We'll see that this is exactly touching the cylinder already, so we can actually stop there. We could stop there But I want to continue so that it will look exactly like what we have done before. So again, center and one of the addresses right here. We run it through the cylinder and then that way. Again, line number 2, center please. Line number 2, I'd like you to see what I'm doing. See, from 2, hitting the surface, going this way and hitting the other surface, coming down to the plan. I'll have a circle going this way. Again, from the center, to line number 3, 3 in the middle. Let's go. Let's see. Yeah, 1 in the middle. What you have here, running down through this point, then going this way. All of them cutting the plan of the cylinder. All of them going through the plan of the cylinder. That way, right here. And from the center, this way, terminating here. Again, from the center, go this way, around, terminating here. So this is what we're going to have, and each of those cutting planes from simultaneously cutting the cylinder and cutting the cone as well, all find an expression on the plan view. So now we're going to do backward tracing. This point here, the first 0, we'll trace it back to the cutting plane in the front view, or the elevation as the case may be. So we have this point going backward. See here, we are exactly correct, and we are sitting on that same point, point 0, coincides with point 0. Let me do the 2 extreme ones that would always coincide, 0 and 0. Okay, here we have 0, also have 0 here, coinciding with 0. Okay, so now I'll do the tracing of the other points. I have point 1, so we have this cutting this point here, and also cutting this point here. We have line 2 cutting the plan of the cylinder there. We have this cutting here, we have this cutting here, and we are back to 0. So this is what we're going to do on this plan, and touching all of this, we will trace all of those points out. I like to label them so we get the right address and know exactly what we're doing. Okay, I have labeled all the points nice and cool. So I have 0 to P0 to P0, like we have always done. Remember, the arcs where they intersect the plan of the cylinder is what we're considering. So we're going to look back. If we look back, we find out that the addresses are correct, and then we can actually project our lines going up. Now let's do a few things. All the lines going up, tracing our points backward. Let's change the colors to orange. Yeah, and then we have, so that we're able to differentiate between both. Now I think it's clear now what we're doing. Yep. Okay. Where 0 intersects 0 is point 1, and then when 1 intersects 1 will be called point 1. I'm going to trace this where 1 intersects this point. This is point 2. Looking for point 3 now. Okay, you don't know what I'm doing. I'm going from 1. Let's start from 0, 0 here. Trace 0 up to 0, 1. That's 1 point. And then we'll trace point 1. Point 1 intersects here, has intersection there. So we'll trace 1 up to where 1 intersects 1. So we have 1 here, we have 1 here, intersecting 1 here. That's another point. So we'll do that continuously and find other point. I have 2 here. I have 3 intersecting 3 here. So I have 1 intersecting 1 here. Sorry, 2. Going back to 2 from 3 to 2, and then we have looking for 1 now. 1.1, 0.1. Okay, has not been drawn, so I have to draw that line vertically upwards right here, so we can easily find the intersection. That point there. Right. Okay, 1 is intersecting 1 here. This is about the only one that has different color, and then we have back to 0. Again, I'll label all of those points and then we'll connect them in proper sequence to see what the curve of intersection looks like. So now, what's next is to join all of those points in proper sequence with a smooth curve. Now you can use a flexible curve or your what's that curve called again? Your curve set to join all the points in proper sequence. Back to point 2, this way, and then up there to 0. So all of those points joined, we can now highlight this. Should the color red. That's where the cylinder actually penetrating. This is the curve you're going to see, and that curve on the plan view is going to appear the circle, this particular circle that we have. So that is all about this. Yep. Okay, the next step to take from here is to develop the cylinder here given in the question. All right, develop the shape of the hole in the cone. Oh, okay, we're here to do that. I want to do this, which is quicker. Develop the pattern of the cylinder using BB same. So using BB same, we have to identify where BB is. It means that we are cutting this part BB and opening it up this way. All right, we open it up this way. So to do that, we have to draw construction lines from where our cylinder starts from. This from O here, that's the maximum height, and the minimum is P naught. Okay, so we're starting from this 0 point to this P naught. So we would have to develop the curve from the point where it intercepts the cone, which is P naught on the cone, and another point is just here. But we need to give respect to the divisions on this line. All right. I think before I go further, let's consider this division. Now you find out that this division we have here is actually into 6. 1, 2, 3, 4, 5, 6. All right. The gaps here are 6, even though we have the numbers alternating. What this also implies is that the cylinder, the part of the cylinder facing us, is divided into 6. Since the cylinder is a circle, what it then means is that the other part, the other half of the cylinder is also divided into 6, which means that as with the principle of the development of a cylinder, if we open up the cylinder, we are supposed to divide it into 12 equal parts. But before we do that, we need to know what distance the cylinder will cover if we open it up starting from BB. All right, to do that, we need to also consider the diameter given, which is 60. So with that, we'll use a formula, the popular formula that we know in mathematics, which is pi d, right? Formula of the circumference is pi d. So pi multiplied by 60. I did the calculation, it will give us 188.5. So we're going to offset that distance from this side, or simply offset a distance that is off the drawing that we have there. Let me take 40 for instance. See how far we can go from here. Yeah, okay, this is perfect. All right. we have this distance 40. So if I want to offset this further, I'll have my compass, no, sorry, my t-square measuring 188.5. Okay, this distance from here, the distance here, from here to here, we have to be 185.5. So if this cylinder were a complete cylinder, this is how it's going to open up, and we can comfortably label, dimension this part before we proceed. Let's do this. So from this point to this point should be 88.5 right here. I have it here, 188.5. As explained further, this distance would have to be divided into 12 equal parts because our cylinder is actually divided into 12 equal parts. So traditional way of dividing is to draw a straight line right to any convenient distance. Use this. All right, I have to divide this into 12 equal parts. That line has to be divided into 12 equal parts. Please, if you don't know how to divide a line into 12 equal parts or in proportion, please observe my video on the division of lines. I've done that before. So to be quick with this, we would simply put a line here from the last point. I've done the division already since I'm using AutoCAD. So I would extend all of this parts across the divisions I have. I have one here. I have another right here. Another 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 here. And another here. Yeah. So I'm going to trim this and label these lines, or these divisions rather, according to the number of divisions on the cylinder, and keeping the numbers alternating like this. So you're going to see that that's what we're going to do. Wow. Okay, I have all the lines divided already and the numbering done accordingly. So what's next is for me to erect perpendiculars on this line so that they would run the line coinciding with the points that we have here on a curve. So to do that, we would simply extend our construction line, erect vertical lines here, 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 and then here. So this is what we're going to have. And let me trim this off so we know exactly what we're doing. Okay, we have our lines erected already. So on this development, okay, I have it labeled true. I have the calculation put there for you to see. All right. For us to start the development, it will start from P0 to P0. All right. So that if we check the division only terminates on the surface of the cone. This is what we're targeting, the curve, not the cone. So we will have to extend these lines and extend the addresses to where the cone is. Yeah, right here. So exactly. So we would have the lines touching here. So our horizontal line, it's going to go from this point. We start from here. Yeah, not here, not on the surface of the cone, but on the curve. So I have one point here, I have another point here. Notice it's not actually coinciding with a P2, P whatever that we have, all right? So, but we can actually use that address and identify if this is P3, we know that the line extending to this curve will be P3. So we can still retain the points like that rather than having different numbers there, all right? Okay, so I have, yeah, at this point, I believe I have every point addressed already. So now what? We would start to plot our curve from P1, right? I look at P1 on the cylinder right here, hitting the curve at this point, and then I'll address P1 right here. But we would have to start from P0. So P0 on my development, this is P0, right? I'll take my P0 straight up, start from P0 right here, and then to P1. P1 is here. I'll address P1. P1, see P1 coinciding with what number? The number I have below, right? It's on this little. Okay, much. I have it here. I have my P2 here. See P2 emanating from P2, touching the curve here, and I'll trace P2 on my development and have my intersection there. P3 the same thing, and then back to P2, P1, and then to P0, 0, exactly touching that point there. And then we go back in the same manner, just the same manner. Okay, right. Have this here, have this here, the last point back to P0, right here. So this is the curve that we're going to have. And to finish this up, we need to check the top of the cylinder because this part of the cylinder was untouched. Right, so we can cut it. This is what's going to have. Exactly. So this is what it's going to be like. All right. So we can trim all of these off. And trim this line 2 off. And let's get some neat drawings. Yep. All right. So this should go up too. Okay. I think you should have this here. And this goes up here. Exactly. So this is going to be our curve. Now let's answer the last part of the question, which says to develop the shape of the hole in the cone. And then to do that, we will have to face the cone and see where the hole is. This is where the hole is on the left. The entire cone is this one. So to develop the hole in the cone, we are going to section this area where there is no hole. Okay? So we'll cut this area where there is no hole. We use this part of seam and draw an arc using this as radius, this length on the sides of the cone as radius. I think we should do that right away rather than talk much. So with O as center and the base of the cone as our radius, we'll draw an arc this way. And now we have a challenge. How long is this arc supposed to be? All right. Now I did a calculation on the other part that I've drawn already. This is the one I produced already. And the development of the cone, to find out the angle subtended by this arc, right? What I did was to transfer the length of this cone this way. The angle subtended by this arc is 200, and the calculation is thus. Here, the base of the cone, the radius of the base of the cone, divided by the radius of side of the cone that we're using now, multiplied by 360, gives us approximately 200. This is the part I'm using as radius. My big R is from O to the base of the cone, and then the base of the cone R. Okay? The ratio of that multiplied by 360 will give me the angle that is needed. So this part is going to be 200. So this is where it's going to stop out, right? Okay, the side of the cone is blue, so we use a blue line to indicate that. This is where it's going to stop out. To produce this is going to interfere with the drawing that I have here. Or better still, something that is doable. So anyway, let's see how it goes with this. That means I'm going to draw a straight line from here. this point, joining the end. That oh, right, opening rather. So we open this cone from this side. This is what we're going to get. It's going to open up to this point. The angle subtending that is going to be 200 that we've calculated already. How to calculate. So now what next? How do we locate this hole right here? To locate this hole right here, it means that this hole is going to be somewhere in the middle of this arc. That's what it means. So if I draw a straight line up to, you have a protractor, locate 100 degree, that will be your middle point, and put a construction line there. So with that point, we mark that point as point 0. Let's take that point to be our 0 point, reference point 0. Copy this and take that point to be point 0. All right, let's say this is point 0. This is our reference point now. Okay, with that as our reference point, we are going to draw construction lines for each of those points on the curve through the development of the cone that we have. This is what I mean. Pick your compass, extend to PO. P0 has an address here, P0, so we'll draw a curve. Pick this point, and draw real lines through that point, culminate here. Same thing with the next point, P2. Radial line to this point, stop there. The next point is P3. Draw radial lines from that point. Okay. Terminate here. Okay. You see the lines coming up beautifully. But if you're using a compass, you can skip this part, this solid diagram, and just create an arc here to touch this point. So really do not have to get to that point though. So generate the next point, which is P2. Stop that here. Point following that is P1 towards the base of the cone. Stop that here. Point after that is P0, last point, and that would also terminate right here. So now what? We would have to develop this pattern on the cone. And to develop this pattern on the cone, we need to find the true length of this point, wherever they are, locate them on the pattern on the cone. So to find out that, the only way we can find that out is on the plan. Find out P0 is exactly on P0, so we're going to have P0 here, right? This point, the reference point P0, 0, right? We're also here on 0, so 0 coincides with 0. So the next point is P1. So with a line joining P1 up there, I use 8.5, 8.4 as my radius. Okay, you could choose this point, this curve, with reference 0 to this point. In actual fact, that is what it should be, because that's the cutting plane, and this radial lines are actually the cutting planes that we have extended. So that's what it should be. So let's hit this point. It's 8.9. That matches radius. Come to P0. Send your compass 8.9. Approximately, I use that because it's an approximate value because of the curve that we have there. It's not exactly correct. So with that much as radius, I'm going to reproduce the same thing on the other side of my curve, right? Okay. Okay. Next point, the curve. going to be the true length on the for P2. So with this as our reference point and this point as our radius, getting 21. So we'll go to P2, this is P2 now. P2, look at P2. The radial line of P2 is this way. I'm supposed to do okay, there's a mistake here. Peanuts and peanuts, so I needed I would need to shift this P1. Because in actual fact it's supposed to be on P1, not peanut, right? So with my compass on P2 and that much radius 21, create an arc this way, and with the same radius I'll reproduce that arc right here. Okay, so the next point is point P3. Look at P3 down here on a curve. We have P3 with O as center, with peanuts this is 0 as center and radius. P3 I have 30, 3 as my radius, and I'll sit on our reference line 0, same reference line that we're referencing on the plan, and with radius 30. Create an arc here, and with the same radius I'll reproduce the same line. I'll reproduce the same line right here. Okay, the next point is P2 to the base. I'll look at P2 here and extend my compass here. I get 30.9, take that as 31. Please note that what we're using is approximate values, right? Sit on P2 and with that radius, same radius, not moving your compass. Create an arc here with the same radius. Duplicate the same arc on the other side of the cone. Okay, I'll check the next one, which is P1. P1 here. So this point is 19.3. Right, with that much as radius, that should be five. There's an arc here. Right, too long. And with that much as radius, without changing the width of your compass, create an arc to replicate the same radius on the other side. So the last point is peanut. Peanut is going to sit exactly on 0, so we do not have issues with that. So pick this up, and peanut is right here to sit here. So the next step. So let's start drawing our curve to create the hole in the hole. So start from this point, P0, P1 from the base, P2, P3, P2, P1, and then P0, up to P1, P2, P3, P2, P1, and back to P0. All right, this is what the hole is going to look like. Represent out the true line. This is what the hole is going to look like. So if you cut this open from here and you reveal this hole on a flat sheet, this is what the hole is going to look like. I may as well label all of these points so that we know what we are addressing and we see what our drawing exactly look like. So let's do that. Okay, I have numbered all the points, and this is what the hole will look like. Zoomed in, right? What the hole will look like. Okay, so with that done, I believe we're done with our work. we may want to shift this other development that we do so that it doesn't interfere with this other one. Yeah, so and do that. Shift it to this other side. Uh, our development to make the drone. So I would post the adjusted material down below so you know how to go about drawing. Here we are back on this drawing. I had to remove the development of the cone from here, transferred it down here. Everything we did in the previous exercise is still the same, except that of course I had to ensure that this angle is actually 200, right? Maybe we should take this up. All right, keep it there. And that was all we did. But of course, if you're using a compass, physical instrument, so to speak, all you need to do is to set your t-square and your set square to copy this line. Copying of lines is a skill in technical drawing. Copy this line at this angle, and then transfer it down here. Now with center 0, draw all the arcs the way you drew them before, and then you will still achieve the same result as we did. Other than that, nothing is different in what we have done. And this line was also adjusted. It was bigger than what it was. So we have to take it back to 200, show that it actually aligns with the angle that we calculated. Okay, I'm going to pin this down in the description below for you to use, and also put this there as a worksheet for you to practice. You can print it out and practice at your own spare time, all right, and ensure that you adhere to all the rules of drawing. Make sure you pay attention to lines, thickness of each line. It's very important. The construction line will lighter and all of that. So keep practicing, and I'll see you in another video.